Okay, so what are the topics that we had covered till date? Okay, in the last class, we discussed about some encoding processes, right? Like how encoding is actually done. Okay, and thereafter we did this Keras encoding, and this the purpose of Keras encoding was just to convert words into vector. Right. Now, why we need to convert the words into vector? The reason is it's like we have to use the text or the words, right, for machine learning. That means I want my machine to learn from the words that I am giving to it. Right. So that's why I have to convert the words into the numerical form. And it's not just about converting it into numerical form. It is also about converting into numerical form in a way that your machine can learn better. Right. So machine actually learns the weights associated with the feature. Okay. If there is any feature that we provide, basically machine learning do what? It just try to learn the weight. That weight means what? That means how much weight is to be given to each feature. So weights are kind of a coefficients that machine learns. Based on the weights, it knows that which feature to be given how much weight is. That is a process of feed forward network and backward propagation. So we need not to worry about that thing much. We just need to understand it at a higher level so that we can understand generative AI process. Right? What we need to understand, that machine learns from the numerical value. Machine learns the so that it can give some weightage to each numerical value. My screen visible? Can you see my screen?
We can see your screen, but voice is again cracking.
Okay,
It's
just
very
just allow
patchy.
me.
Yeah.
All right, understand. Actually, that's why I asked, because I was little tracking, so that's why I'm asking you. Just allow me for a minute. I'll just just allow me for a minute. All right, team. Now you will get my voice clear. I was just connected with my phone network, so that's why my voice was little cracking, but I changed the network now. All right, so let's move ahead. Okay, I'll to make the voice smoother, I'll just close the video for processing. Okay, so let me just go through the things that what we covered till date. It was about word embedding. Word embedding is just a process through which we can convert the words into the numerical form. Now, after converting into numerical form like this, Okay, here we converted the words into simple numerical form. And then from this numerical form, we are creating the vectors for each word. Okay, why it is important to convert the words into vector, so that we can let the machine learn about the words, right? Now, these numbers are actually representing words. This is one word, this is second word, this is third word. So now machine can easily learn about each word. Now, once it is converted, we have to see how a machine can learn from it, right? So if I want a machine to learn from it, we need to do a hands-on. So for the hands-on, what we will do today, we will define some text, okay, and we will assign the label to the text. Okay, for example, let's say I have a document. Okay, in that document I have two kinds of information. Okay, let's say I have a document over here. Let me just try to write it. I'll open up Paint. Okay, so let's say I have a document over here and I have two kinds of information in that document. One is there is a information about cricket, okay, and there is a information about chess. Okay, so there are some text are there for the cricket, then there are some text are about the chess. Okay, what we want, that machine should learn from this text, and later on, whenever a text is given to the model, okay, whenever a text is given to the model, so model should recognize that whether the text belongs to cricket or the text belongs to chess. Okay, model should be capable of recognizing, like suppose I give the model that I want to play chess, or Viswanathan Anand is a very good chess player. So model should know that, okay, I'm talking about the chess, right? So this is a simple case study that we will try to do over here, right? So 50% of the thing already we did. Okay, up to here we have to do the same thing, right? After this, we have to just prepare a model. Okay, a machine, a kind of a neural network model, right? So let's try to work on it. See, if I need such kind of application, so for that, first thing what we require, data. For any kind of machine learning, deep learning, neural network kind of application that we want to create, the first thing actually we require data. GPT is also trained on huge amount of text data. Okay, LLM, any LLM, GPT, Gemini, Llama, whatever, any LLM is trained on huge amount of text data. So let's define over here data. Okay, we'll just define our own data, right? So in this data, let's say text is equals to, we will define few texts over here. The first text I'm defining, let's say about the cricket, right? So let's say here, just allow for me. Okay. Here I'll define, I am playing good cricket. So it is what? This is a text about the cricket. Okay, let's define one more text. This time, let's define a text about a chess. He is playing chess. Okay. Thereafter, let's say we'll define over here one more text, because I want to train it. So at least 6 or 7 texts I'll define. I like to watch cricket. Okay. Thereafter, chess is a mind game. Okay. Cricket is played outdoors. Okay. Then chess pieces are interesting. Okay. Thereafter, we played cricket yesterday. Okay. He won the chess match. Okay. So these are some text I have used. Now, in this text, the first is about cricket, the second is about chess, then cricket, then chess, then cricket, then chess kind of thing. So it's like we will define over here labels. okay, that are called target. So let's say the cricket I want to label as 0, okay, and chess I want to label as 1. So it should be 0 1, again 0 1, okay, and again 0, and this is 1. This is our first lab exercise in which we will see how actually machine learns from the text. Okay, how actually a machine learns from the text, right? So here we have assigned label 0 to cricket, and we have assigned label 1 to the chess. All right, done. Now, if I want to use it for the learning process, that I want machines to learn from it, what should we do? Let's relate with what we did earlier, okay, so that we can better understand. So earlier what we did, I have to convert the text into numerical form. So to convert into numerical form, I need to first create the tokens. Tokens are what? Each individual words. All right. Tokens are just the each individual word. So this guy will take care of tokenization. Right. Next, what we did earlier. See, when the tokens will be created, each time it's not necessary that we have an equal length. Okay. Like over here, this guy is having how many words? 1, 2, 3. Okay, 5 words. This guy is having 4 words. This guy again have 5 words. So ultimately it will create a unstructured data. For some sentence we have 5 words, some sentence we have 3 words, 4 words, like that. So I want a structured data because machine always learns from the structured data, right? So to have the structured data, what we did here, we used padding. Okay, like here these are representing your actual sentence. The sentence is having 4 letters. The space which are where we don't have any words, they will assign 0, right? Because the longest sentence is of what? 7 words. All right. So for that, this guy will take care of the padding. So I'll just import it. This library will take care of what? Padding. All right. Next, I need word encoding, right? That is embedding, right? So for the embedding, we are using what? We are using Keras TensorFlow. This guy is taking care of embedding over. That means this guy is like, we are just giving the information to this particular library, and this library is giving me what? At the end, vectors. Okay, this library is giving me vectors, right? So just pick up this library, okay, and it will give me vectors. Okay, now when we get the vectors, actually it's a kind of a matrix that would be created. And to manage the matrix, okay, to process the matrix, we required one more library of Python, which is called NumPy. Okay, NumPy library is used to handle or process the matrix numerical, data. Numerical Python. The full form of NumPy is what? Numerical Python. So these are the 3 libraries we are importing that we had imported earlier as well. All right. Now, once we have these library, what we do first? Tokenization, right? So for the tokenization, just tokenize it. Tokenizer. How we tokenize it? Let's again get back to the previous class. Okay. So in the previous class, what we did here we tokenized. Okay. For the tokenization, we need to define an object of tokenizer library. This object will do the tokenization. Tokenization means what? Just access each word separately. So this guy will take care of tokenization. All right. Now, how it will tokenize? It will tokenize when we provide the text data to it. How are we giving the text data? We are giving the text data using fit on text. Okay. This is what we are doing. Okay. So when we do it, it will just convert each word, each sentence into individual words. Okay. And those words we can see like this: tokenizer, okay, dot word index. Okay, so what this guy did, you can see over here, our whole sentences are there. From those sentences, all the individual words picked up, all the unique words picked up, and they had been assigned a particular number. Right now, using this number, what we did, using this number, we created over here the sequence. Okay, sequence of number representing a particular sentence, sequence of number representing second sentence, sequence of number representing the third sentence. Right. So same thing we have to do. So let's pick this thing up. Okay, and here we will do what? Text to sequence. And I'm using what? Tokenizer. What is tokenizer? Tokenizer is the same object, okay, which knows about our text. This is the same object which knows about our text because we had used fit on text method. Using fit on text method, we had given the information about the text. Anyone is willing to join? No, thank you. So it's like this guy knows about our text. Okay, this text is containing the values. This knows about the text as well as it knows about the numbers for each text. Right. So now if I will call over here the sequences, right, I will get the sequence of numbers. Okay, but this sequence of number is what? Unstructured. Okay, where we have some sequence 5 numbers, some sequence 4 numbers, like that. So obviously without padding, it can't be done. Like we have to just do the padding so that it can be properly adjusted, right? That means all of them can have the equal value, isn't it? So what can we do? The maximum length is what? 5. Over here the maximum, you can say, length is what? 5, right? So as we have a maximum length 5, so I can define maximum length is equals to 5. Okay, and thereafter we'll call pad sequences. What is pad sequences? Already we imported here. Check here. Okay, this particular class that we already imported from the Keras. Okay, TensorFlow Keras, which will take care of padding. So we can just feed the sequences over here and it will perform the padding. Now, when it is performing the padding, it is performing what? Pre-padding, right? So there are other factors that we can also define over here. If I want pre or post kind of thing. One more thing we can define: maximum length. So maximum length is equals to what? This is what we can define. It will not, it is not mandatory. There is no change, but yeah, this is a parameter that we can use in some case. Thereafter, we have over here padding. So by default, it is a pre-padding, but if I want post-padding, that also I can do. But most of the time, this is a post-padding now. But most of the time, we work on the pre-padding because pre-padding is more effective if we are working on a particular model for the text prediction. Okay, if I have to do the text prediction, that we will do also. So this is a padded sequences. All right. Done. So once we have a padded, that means now we have a data in the numerical form. Okay. And then we also have the labels, right? Here is our labels. We also have the labels and we also have the data. All right. Now we will try to kind of build a model. We'll try to do what? First, try to do the embedding, right? First, we have to do what? We have to do the embedding that we did here. That will convert the things into vectors. Okay, we have to do the embedding that will convert the text into vectors. This one. All right. So how to do embedding? Let's do it. So first, here now we had seen over here, we had used it for padding. We had used it for tokenization. This guy used for tokenization. This guy used for padding. Now this one is left. Okay, this one will be used to create your model. Okay, a model which can do embedding, a model which can be used for learning. Okay, this guy will be used to create your model. Okay, a model which can do embedding. Okay, and which can do what? Learning. Okay, learning about your text. Embedding will be process where each word will be converted into a vector. Learning is something which will learn from this vector to predict something. Okay, learning is like learn from these vectors and the labels to predict something, right? So let's try to implement it. First, I have to define model is equals to what? Models. What is models? Models is a inbuilt models is the inbuilt class of Keras, which is used to define your model, the neural network model. So here, what are we defining? Models.sequential. This will be used to define your model, which is a sequential model. And what this sequential model will do? This sequential model, so it is like define a model for neural network to learn from text. That's it. Okay. So what we have to do over here? See, first I need to convert these words into the vector. Okay. Each word we have to convert into vector. Now, what I told you, how words are converted into vector. See, here I had explained you. Had I explained this thing? It is not mentioned. Anyway, let me just try to explain once again. Okay, I already explained it, but this thing needs a multiple. Like it's difficult to, because you're learning from the for the first time, and many of you may not have that expertise in machine learning. So I can understand. I may have to explain this. I should explain this once again. So here I have the words. Okay, let's say what are the words do we have? Let's say I am playing good cricket, right? So how this guy will be converted into vectors? What vectors? I am playing good cricket, right? So this guy will be 1, this is 2, this is 3, this is 4, this is 5. Already we did this thing. Already we did this thing. Now I have to convert these things into a vector. Okay, like 0.13, 0.15, 0.17, 0.19, like this. Okay, I have to convert it into a vector, right? So how this thing can be converted into a vector so that machine can learn better from the vectors. Okay, so how it can be converted into vectors? Let's try to understand. First step is like these guys will be converted into this kind of form. Why only 5? Because here I am considering 5 words. Okay, how many words I am considering? I am considering over here 5 words. That's why. Okay, I am considering 5 words. That's why 5. All right. So these guys are converted into the 1 and 0. This is called one-hot encoding. Now from this one-hot encoding, we will create a neural network. Okay. In this neural network, we can have 5 neurons. Okay. Now I have to define the size of output vector. So let's say size of output vector is 3. All right. Okay. Now what happened? These guys will be connected to this output neuron like this. All right. Now I have to convert I into a vector, right? So how are we representing I? We are representing I like this 1 0 0 0 something like this, right? So here 1 0 0 0 0. Okay. Now your algorithm, your Keras library will do what? Will assign some value to these neurons. Okay. So these weights. Okay. Like this. They had been assigned some values. Once they had been assigned some values, so based upon the neuron input, okay, based upon what? Neuron input, this guy will do what? 1 into 0.1, this will get a value 0.1. Okay, then same process will happen for others, like this guy. Okay. Now over here also some value, because you know these are 0.2, 0.2 multiplied by 0 will remain 0, right? So the it is like 1 into 0.1 plus 0 into 0.2 plus 0 into 0.1, all right, plus 0 into 0.3. Okay, so it's like all of them become zeros, only 0.1 will be there. Now here it's like something else like 0.2, 0.3, 0.5, 0.6, 0.6, something. Okay, these are the random value. This random value actually defines so that each word can get the different vector. Okay, that are basically each word can get the different vector, and same word when appearing for the next time should get the same vector. So actually machine learns about these things so that it can give a particular vector to each of the word. Now based on it, again 0.2 will be the output. Okay. Then what happened? This guy will be, sorry, this guy will be connected over here. Okay. Again, there will be some random value defined and it will learn. Okay. 0.3, 0.7, 0.8, 0.9, 0.5 like this. Okay. Or let's say 7. So based on the 0.3. So I over here represented by what? 0.1, 0.2 and 0.3. All right. Next comes what? I am. Okay. I am. So for I am, for the M input is what? 0, 1, 0, 0, 0. Right. Now this particular neuron is active. So for this neuron, the output for the first output neuron will be what? 0 point. You can see 2. Okay. Second output neuron is what? This is 0.3. Okay. And third output neuron is what? 0.7. Okay, so here the M. So I was represented by 0.1, 0.2 and 0.3. M will be represented by 0.2, 0.3 and 0.7. In this way, each word will get the different vector. This is called what? Word embedding. Each word is getting what? Different vectors. So the same process we have to do over here. We have to just create a layer into the model by using model.add layers dot embedding. Okay, these all things will be done by the library itself. Okay, why library? Why can't you do on your own? Because it's a huge number of weights. We can't manage manually. If we try to manage it manually, it will be kind of a problem, right? Yeah, Gaurav, just allow me for a minute, right? Let me just finish it. This slide. Once I finish this slide, I'll take your query. All right. Now, here I have to pass 3 different parameters. One is called input dimension. Second, it is output dimension. Okay. And third parameter I have to give over here, input length. Okay. Input underscore length. Okay. So what is required? What is input dimension? Input dimension over here, if you see, what is input dimension? Input dimension is like how many number of unique words do we have? Okay, what is input dimension? How many number of unique words? Right. So how many number of unique words do we have? We have the unique words that are over here. Okay. These are our unique words. All right. Now with these unique words, I have 24 unique words. So I can take the length of it. Okay, if I have 10, 24, here I have 5 unique words. So 5 unique words are converted into this form. So 5 input neurons. Here I have 24 unique words. So there will be 24 input neurons. So I have 24 unique words. And thereafter we have plus 1. Why 1? Because 0 is also there that we had added after padding. Okay, 0 we have added after padding. So this is what? This is your vocabulary size. This is the total number of vocabulary that we have. So we have 24 values. So that means I have to initially create the this particular vector will be size of 24. This vector will be size of what? 24, because in my document I have 24 words, right? So input dimension, I have to let this guy know that I am having 24 input words. Then output dimension, that I can choose as per our requirement. Like if I'm creating a larger model, I can, like suppose I'm working on very large amount of text data. I have suppose 10,000 words. So to represent 10,000 words, we need at least a vector size, output vector should be at least of 50. Okay, so that model can learn better. Here I have just 24, so it is we can just use anything, like suppose 3 or 4 kind of thing. Okay, whatever the embedding size we require. Okay, let's say I want the embedding size over here, embedding dimension. Let's say embedding dimension is 3, right? So this is what I can do, right? So embedding dimension over here. Okay, and last, it is input length. What is input length? Input length is what is the maximum length of a particular sentence. So it is 5, right? So I can just define over here 5. Okay, so this is a process that we did in last class as well. If you check over here, okay, this is what we did. And after doing this, we did what? We just fit the data. After we did this thing, after doing this, here we did it. Just a minute, let me show you the program also. Yeah. So here we did this thing. Okay. After doing this, we fit the data. Okay. After doing this, we fit the data into the model. First, we define the model. We added a layer which is responsible for embedding. Then we fit the data, right? And the data is converted into vectors, right? So after this, here we will not fit the data directly, but we will build the neural network which will learn from this embedded vector, right? So this is a layer to create word embeddings, which are called word vectors. Okay, so this is something which will create the word vector, and this layer is responsible for that. Yeah, Gaurav, please. Thanks, Gaurav. Thanks for raising your hand. Okay, and please let me know if you have any question to ask.
Yeah. Hi, thanks.
Mhm.
I have two questions. One, like we decide what will be the size of the output neuron, correct?
Correct, correct.
And on which basis is there any logic to decide? Like you said, for 1,000 we can use 50. We have a small data size, so we use 3 or 4.
Mhm.
Any
Mhm.
logic behind it, or is
Mhm. Okay. See, when we define this output vector, there is no such mathematical formula through which we can calculate. It's just a kind of a, that is called what this is known as. Mm, there is a term that we use. Mm, Trainable parameter. There is one. This one, someone is joining. There is called trainable parameter, and there is called hyperparameter. All right. So this guy is actually a hyperparameter. Right, hyperparameter is something that we define. Okay, trainable parameter is something that machine learns. Okay, like these are what trainable parameter, these weights are what trainable parameter, that your algorithm will identify these trainable parameters on its own, but these are hyperparameters that we define, right? So now on what basis we define? See, first of all, it's just based on your experience. Okay, and second, when we define it, we build the model and then we check the model performance. If my model is underfit, okay, underfit means what? It is not giving the accuracy that we want, right? So it means what? It is learning lesser number of weights, and weights will be directly associated with how many neurons we are giving to it. Okay, if I give more neurons, it will learn more weights. If I give less neuron, it will learn less weight. So if it is underfit, we increase this thing. Okay, we increase, because after this, what happened? Hmm. After we created this embedded vector, what we have to do next? Next, we have to create the neural network like this. Okay, these
yeah,
are our embedded vector.
so we
These
have
are
started
actually,
because
yeah.
like no,
Sorry.
Are you showing something?
Yeah, I'm showing something.
Means you are drawing something, yeah?
Yeah, I'm drawing. I'm drawing. My screen is not visible.
No, no, no.
Okay. Why? Let me just
Only your
re.
screen is visible, but the annotation is not happening.
Just a minute. Let me just try to resave. Sometimes glitch happen.
So you can say the rule of thumb is if more number of
Now,
uh,
is it visible? Can you see my screen?
not yet.
Yes, sir. Yes, sir. It is visible.
You can see my screen. Gaurav, can you see my screen?
No. Anyone else? Please confirm.
Yes, yes, yes.
Okay.
It is visible.
Gaurav, can you just refresh that rejoin? Just a minute. Let me just a minute. Gaurav is still joining or what? Just 1 minute, okay? Okay, can you see my screen now?
Yes, sir.
Gaurav, can you see my screen? Gaurav, please confirm if you can see my screen or not. I can't hear you. Gaurav, can you see my screen?
I can see your screen now. Hi, sorry. So you are on mute, I guess.
Now you can see my screen, right?
Yes, yes. Thank you.
Okay.
Thank you.
Okay. So let's again rephrase your question. You asked me like on what basis we define. So here we define it based upon based upon two factors. First, on the size of data. Second, we just define any random number. Okay, based on our experience, based upon the kind of data we are using. Now, when we define any random number, there will be an output vector, obviously, right? Like this, there'll be output vector for each word, correct? Now, using this output vector, what we do, we go for the next step. In the next step, since we have an output vector of size 3, and I want my machine to learn for each word. Let's say my machine wants to learn about I. So I is represented over here by 0 0.1, 0 0.2, and 0 0.3. So this neuron will be given 0 0.1, 0 0.2, and 0 0.3. And after this neuron, there will be a hidden neuron, layer of hidden neuron, and there will be a layer of output neuron, right? Now what happened? These guys will be connected like this. This input neuron will be connected to hidden neuron like this. right? All of them are connected over here, right? And now it will be connected like this. Okay. Okay. All right.
So these
So
hidden neurons, what purpose they serve?
okay, I'll complete. I'll complete. Okay, you'll understand. Just a minute. Okay. So now it will be connected like this. All right. Now what happened? First, embedding is done. Embedding had given me the vectors for each word. Now those vectors we will feed into another neural network. In this neural network, we have 3 input neurons, and then we have some number of hidden neurons. How many hidden neurons? Again, it will be defined randomly based on the size of input neuron. Like suppose size of input neuron is 3, so here we define, like generally we define it in the multiple of 16, like 8, 16, 32 kind of thing. So now why this hidden neuron we define? We define the hidden neurons so that your model can learn about these input neurons and output. Okay, like I had given over here I, right? So if I want a machine to learn about I, so like suppose what I want my machine to learn about this complete sentence. Okay, so this complete sentence is representing what? This complete sentence is representing a sentence about cricket, right? This is having how many words? 1, 2, 3, 4, 5 words. Each word is represented by the vector of size 3, like 0 0.1, 0 0.2, what is it? 0 0.1, 0 0.2, 0 0.3. Each word is represented by a vector of size 3. Each word is represented by a vector of size what? 3, right? So it means total how many numbers will be there? 5 into 3, 15. 15, right? So
Yes.
here we will have 15 neurons. Okay, like this. Just a minute. 1, 2, 3, 4, like this. You can just consider it like this. Okay.
Hmm.
So now these 15 neurons are all connected. Just a minute. So these 15 neurons are all connected to this hidden neurons. Like this.
Got it.
Okay. Like this, right? Over here. You can just assume like all of them are basically connected. All right, like this. All right. Now we have 15 neurons. So these 15 neurons are representing one complete sentence. Okay. This is representing what? One sentence. Okay. And the output will be representing what? 0. Output is what? Over here, my actual output is what? 0. Right. Now, based on the value that we give over here, each neuron will get certain value. Okay. That comes from the vector we have. Okay, now these values will be, these values will get multiplied with these weights. Okay, here there will be some weights. Okay, some random weights will be there. Okay, like suppose here weights 1, 2, 3 or something like this. So it works simple like this. Suppose I have input value 3, 4, 7. Okay, and then I have a hidden neurons like this, and then I have output neuron. Okay, let me just try to make it more simple. Let me just try to use only 2 hidden neurons so that it can be easy to understand. Okay, 2 hidden neurons, right? So here, like this, right, and then output. Now let's say here I have a value 1, here I have a value 2, here I have a value 7, here I have a value, let's say 2, here I have a value 3, here I have a value 4, like this, right? So this will be calculated using W naught plus W1 into X1 plus W2 into X2 plus W3 into X3. W naught value, let it be 1. W1, that is weight value, is what? 1 multiplied by 3 plus this is what? 2 multiplied by 4 plus 7 multiplied by 7. So here I got a value what? 49 plus 4 into 2, 8. 49 plus 8 will be 50,
And
57. 57 plus
next neuron channels
61.
will also have some weightage. Correct. Like this will get two
Correct, correct,
values.
correct.
ठीक है. Got it.
Correct. Okay, huh, right. This one get a value 61. Same way, this one also get some numerical value. Let it be,
Numerical
you
value.
can calculate it like 2, 3 into 2, 6. 6 plus 7 into 4, 28. So 6 plus 28 is 34. And this is 7 into 4 again, 28. So again, it would be 34 plus 28 will be what?
62.
62. Okay, let it be. Whatever, if it is incorrect, then it is just right. So now here there will be again some weight. Okay, let the weight over here 3 and 2. So 61 into 3 is what?
183.
61 into 3. Whatever,
183.
like
जो भी.
like whatever, let's say x like 2, 556 something you are getting. Anything, I just give the random value. So now here I got the value 256, but real value here, the actual level is what? Let it supposed to be 0. So it is expected that this value should be close to 0, but it is what? 256, right? So feed forward network, the feed forward process had given you some value. After we have some value here, there will be an error that will be calculated. What is error? Error is equal to 0 minus 256. That is equals to minus 256. So my error optimization process, that like gradient descent or atom, again lot of error optimization processes are there. Those error optimization process will trigger the backward propagation. Backward propagation will tune these weight values. Okay, backward propagation will do what? Will tune these weights values step by step using a particular process, particular gradient descent process, so that these weights value can change in that direction in which this error can be minimized, right? So this process will go again and again so that this weight value can be optimized, can be tuned up to a certain extent so that this value can come as close as possible to expected value, right? And at the end, your model will learn about these weights that are called what? Trainable parameters. That means it will learn about these parameters. Okay, that's the purpose of these hidden neurons. If you increase the number of hidden neurons, what do you increase? You increase the number of weights, right? Isn't it? If you
Correct.
increase the number of hidden neurons, you are increasing the number of weights. Or if you are increasing this vector size, then also you will increase the number of weights, right?
Correct.
So when you are increasing the number of weights or decreasing the number of weights, there can be three situations possible. Situation one, if your number of weights are lesser than required, it will be an underfit model. Model accuracy will be poor. If your number of weights are more than it is required, right, it will be an overfit model. That means model learns a lot about the existing data, but not performing on a data which is not known. Overfit is like model learns everything. Like you have created so many weights that model learns everything about this data, right? You created so many weights that model learn everything about this data. But when anything outside this data we are giving, it is not performing well. So we have to avoid underfitting and we also have to avoid overfitting. And for that, we require optimum number of weights. So how do we find out the optimum number of weights? Again, there is no mathematical formula for it. It is like we train, evaluate, tune, right? Or we use some other things like a dropout we use, in which we randomly say that, okay, in every iteration, just drop 30% of the weight, use only 70% of the weights, okay? Just to control that it should not get overfit and it should not get underfit. Okay, so that's how we define. That's why I said whenever we have a very large scale data, generally we define, we increase this thing. Okay, if I have suppose 10,000 or 1 million things, so we make this vector of size 50 or 100. Okay, generally we make a vector of size like a GPT. For the GPT, each word vector is of size 342. Okay, GPT had also used text to train the model. Now, when GPT had used text to train the model, they had created the vector of each word The vector of each word they are using is of size 342. So 342 is good enough, right? And then those 342 vectors of each word they are feeding into the neural network so that model learns about those words or sentences. All right. So here we did what we already created when we did this thing. Okay, this guy will create the vectors like this. Okay, now this is representing your complete sentence. Okay, this is representing your complete sentence in which each word is represented by what? Each word is represented by a vector of size 4. Right? Each word is represented by a vector of size 4. Now these guys will be flattened. Flattened means what? It is 1, 2, 3, 4, 5, 6, 7. If I want my model to learn about this sentence, I want my model to learn about this sentence. So 4 into 7. 1, 2, 3, 4, 5, 6, 7. 7, that is 28. I will create a 28 neurons. Okay. If I want my model to learn about this sentence, I have to create what? 28 neuron for the next step. The first step is done. Now we are moving to the next step. Right. So for the next step, what we do here, we will simply add one more layer. The responsibility of this layer is what? Is just to flatten the output. Okay, just to flatten the output of previous layer. It will just flatten the output of previous layer for each sentence. We have how many sentences? 8 sentences, right? So for each sentence, it will flatten the thing. So it will create the input layer. So now this thing is done. Flattening is done. Okay, here we have flattening. Now I have to add hidden layer. Right. So for adding the hidden layer, here we'll add one more thing, model dot add. Okay. Model dot add. Okay. Here it is layers dot dense. Okay. What I have to do, I have to just add over here 8, 16 kind of thing. Generally, if it is very small size model, 4 we can use. But there is no such rule. But most of the time I had seen people are using 8, 16, 32. Now I just try to find out the reason that why most of the time people are using 8, 16, 32, 32, 64, 128, 256, and so on in the multiple of 16 basically. So I find the reason that our neuron system, that human neuron system, is actually arranged like that in a multiple of 16 neurons. So people try to replicate it. That's the reason. There is no mathematical reason I find out. This is something I find out, but there is no such rule. You can use 5, 10, 70, 20, 30. It's up to you. Okay. So here we are using 5 hidden neurons, and then we will add over here output neuron. Okay. So here, this is what? Flattening the embedded vectors to feed into neural networks. Okay. And here what are you doing? Hidden layer with 5 neurons. Okay. And here it's an output layer with 1 neuron, as we need to predict 1 or 0. That's it. All right. Now here this model is done. Let me just try to check the summary. Vocab size is not defined. All right. Vocab size we have defined here. Why it is saying not defined? Okay. These guys should show me a number, but is not showing me a number. Input length is depreciated. It is showing a warning and it is not showing a number. Okay, no problem. It may be some library update maybe going on. It is not a big problem. It should show me actually the what number it should show. It should show me a number like this, that it actually shows the number of weights. It shows the number of weights over here, right? But it's not showing. So I'll just cross check. I'll just cross check why it is not showing, but that will not affect the model performance. Okay, maybe some library update is going on. That's why. Now here we have to, once my model is done, we have to compile it. Okay, so compilation requires three things. Optimizer, that who will optimize the error. Okay, like I told you here, your input neuron value you are giving, you are given the input neuron value. Input neuron value is what? Is the vector, what vectors? Then we have a hidden neurons, then output neuron. Now here output will be calculated based on the calculations. This guy will calculate the output. Okay, this output will be compared with real output to find out error. Okay, and that error needs to be optimized. Optimized through what? Backward propagation. This error needs to be optimized through what? Backward propagation. Fair enough? Right. So who will optimize? So there are a lot of optimization algorithms are there. One of the very popular optimization algorithm called Adam. Okay. Adam is an optimization algorithm. If you see Adam optimization optimizer, right? So Adam optimizer sort of adaptive moment estimation, a popular efficient optimization algorithm used in machine learning, particularly in deep learning. Okay, it combines the advantage of two optimization technique, RMS, prop, and momentum, automatically adjust the learning rate for each parameter, making it adaptive. So now, do we need to go into depth of the Adam? You can go into the depth of the Adam if you are learning neural network in depth. Okay, for this particular course, you need not to go in depth of the Adam. If you are going through the course of deep learning, neural network, okay, so if you are ever going through the course, if you are trying to learn deep learning or neural network in detail, then you should go into the depth of it. Okay, for generative AI, it is not required. It is just you need to understand that how actually model learns from the text. So we just need to use it. Thereafter, we use the second parameter, which is called loss. Loss means what? How to calculate the error, right? Here error is calculated. How it will be calculated? It will be calculated based on the output. What is output? Output will be either 0 or 1. Okay, output that we have defined is what? Either 0 or 1. So with respect to this output, I have to calculate the error, right? So that's why I have to use, whenever we have two outputs, this is a binary output. So we use the error cross entropy. That means calculate my error with using binary cross entropy formula, and then show me the accuracy. Okay, these three things we feed. Optimize using Adam. Let me write it over here. Optimize the error using Adam, right? Calculate the error using binary cross entropy. Okay, and then show the accuracy during learning process. Okay, so once we compile it, thereafter we use it to train, right? So let's try to use it to train. So for training, we have to use model.fit. We have to feed two things now. Train your neural network model. Train your neural network model to recognize a text is about cricket or about chess. That's it, right? So okay, dot fit. So here what I have to do? I have to fit thing. What I have to fit? I have to fit the padded sequences. So when I fit this padded sequences, This guy will convert it into the vectors, word vectors. Those word vector will be flattened, will be given to the neural network, and then neural network will try to learn from it. So here we did it. Next, we feed over here labels. Labels are what? 1 or 0, right? And next we feed over here how many times I want to train. So I want to train it, let's say for 30 times. Okay. So if I want to train it for 30 times, so let's say what happened after 30 times, we get an error over here. Okay, fine. Unrecognized data type. When we are doing this thing, it is giving me an error that it is not recognizing this guy. Okay, so it is why it is not recognizing this guy. It should be recognized. Is it not? Just a minute. Let me check the type of it. Last time it worked, right? It's a NumPy error, so it should work. Why it is saying that it is not recognizing? Something I'm doing incorrect. Just a minute, let me check. We had over here this padded sequence. In this padded sequence, we had given over here. So it should work, right? Why it is showing me an error? Padded sequences when I feed, input length is fine, vocab size is fine. Unrecognized data type. Why it is showing me unrecognized data type? It should work. Happen. Flattening is already done, and dense is already used over here. Everything is good. Uh, this should work. Let me just try to check over here, explain error. This thing should work, or I may be doing some very small, because this is how we did it and it work. Okay, so what it is saying, the error occurs because the model accepts the label to be, oh, okay, fine. Understood. See what happened. I'll tell you. I'll tell you what happened. Actually, just let me just remove it. Okay. So what happened actually? See, it is something that we are giving for the input. Okay, to convert the text into vector and then use the vector for the training. Okay, what are we doing? This guy actually we are feeding over here to the model to convert it into vector, and then that vector we are using into neural network for the learning process, right? And we are using this label as a target column, right? That means I want my model to learn what is the relationship between this and this, right? I want my model to learn about this and this, because this is representing my text and this is representing the label for that text. This is text, this is label for the text. So I want to find out what is the best relationship between it. Okay. So what is important? Important is like both of them should be of same data type. Okay. But if I will check the data type of this guy, type of label. Okay. It is, see, this is NumPy array and this guy is what? List. Okay. Labels is what is a list over here. Okay. List is another data structure in Python. Okay. Array and list is having slight differences. Array is basically homogeneous. Okay. Like array can't have data of different types. All of them will be numerical. But list can have the string data, non-numerical data, any kind of data. So I have to convert this guy into NumPy array. So labels is equals to np.array labels. Right. Only this line of code is equal. So now it is converted into array. Right. So your input and output both should be what? NumPy array. Now it will work. Hmm. Data cardinality is MB makes your all array contain the same number of sample. X size 8, size 6, Y size 6. Okay, so here I am fitting what? Okay, there is one more problem. We have 8 samples, right? But the labels that we have defined is only 6, right? So this one also I have to fix. Okay, so here it is cricket is 0 and this is what 1. Okay, labels should also be 6, right? Because sample size is 6, sorry 8. So sample size is 8. So sample size is 8. So label should also be 8. Now everything is work. Now I expect it to work at least. So now it is working. Okay. But if you see over here, I am getting accuracy only 50%. Okay, which is obviously not a good accuracy. Now, why are we getting the accuracy 50%? All right. So let's get back to your neural network. Okay. So this neural network is doing what? This neural network is first converting the text into vector. That vector is converted into the input neurons, then hidden neuron, then output neuron. So the process that is happening over here, this process. Again, let me just try to do it here. I have, let's say this is the input. This is representing my word vector. All right. This is representing my word vector. This is representing my hidden neurons. Fair enough. This is representing my output neuron. All right. Right. Now let's say this is connected over here like this. Right. This is connected over here like this. Okay. And this is connected over here like this. All right. Now here I have value, let's say 0.1, 0.2 and 0.3. Okay. Now we have some weights value. Okay. Let's say weight value 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1. Okay. So let's say these are the weights values. Based on weights values, when we calculate the output, this particular neuron value, what will be the neuron value? This neuron value will be 1 into 0.1 plus 2 into 0.1, that is 0.2. Okay. Plus 0.3. Okay. I'm not considering weight, not let it be 0. Here it will be 0. 0. What? 0.4 plus 0.2 plus 0.6. Here it will be what? 0.1 plus 0.8 plus 0.3. Just randomly I have defined any weights. So based on this, what will be the output? The output over here is 0.3, 0.6. Okay. Here it will be 1.2, 0.6, 1.2. Here it will be what? 9, 10, 11, 1.2. Right. Now again, it will be connected over here. Okay. So let it be 10, 20, 10. Right. So 10 into 0.6 will be what? 6 plus 20 into 1.2 will be what? 2. 20 into 1.2. It will be 12 into 2 is 240, right? 24. 240. So it's 24, right? Plus it is what I am just using, let's say 10. So 10 into 1.2 is 12. So this will be equals to what? 12, 20, 48. Okay. So here the output I am getting is 48. But actual value is what? 0. Right. So error is what? 0 minus 48. Now your algorithm needs to tune this error. To tune this error, your algorithm needs to do what? Change these weights. Okay, it needs to change these weights in a direction in which your error can be minimum. Okay, your algorithm needs to change these weights in that direction in which your error can be minimum, isn't it? So it will change its weight, but the problem is here the linearity. Okay, we know that we have calculated the outcome over here as 48. These are the, suppose value of input neurons. These are some weights came. Based on these weights, the value of these hidden neurons calculated. Based on the value of hidden neurons, the value of output neuron calculated, and we get 48 as output. Now I want that this value should be closer to 0. So error is calculated. Now these weights needs to be changed. Okay, I have to change these weights so that error can be minimized. But the problem is I have to reduce this it's very large weight, right? So we break the linearity of y, because if I don't break the linearity, this value can be anything. It can be 3,23395. It can be 72165. Okay, it can be minus 8,321. It can be anything. It can be, minus infinity to positive infinity. Right? This output neuron value can be from minus infinity to positive infinity. It can be anything. Right? And in that way, your algorithm, your process will become complicated. Your model can't learn these weights. Not possible to learn these weights, because every time it is getting value in different, like sometimes it becomes very large, sometimes it becomes very small. Right? So as these output neurons value become very small and very large, so your model is unable to learn the proper weights. So we do what? We break the linearity. And for breaking the linearity, we use an activation function over here. And the activation function we use over here is what? Is a sigmoid activation function. I told you, I'll tell you about it. Let me first use it. Sigmoid activation function. Okay, I just added an activation function called sigmoid activation function at the output layer. And when I add the sigmoid activation function, then again I train the model. So you can see the accuracy now become 100%. So what magic it did actually, what sigmoid activation function did? Okay, sigmoid activation function over here actually breaks the linearity. Okay, sigmoid function using this particular formula, right? Using this formula, where is the formula? Here is the formula. Okay. Using this formula, it breaks the linearity. So let's try to understand this formula. All right. So see what happened. I have a input neuron. I have a hidden neuron, right? Like this. Then I have a output neuron. The problem is linearity. Because of linearity, I am getting the value of output neuron from negative infinity to positive infinity. But my real target was either 0 or 1. But my real target was either 0 or 1. So it is getting difficult for the algorithm to optimize weights. So I am using this particular formula at the output layer. So what this formula is saying, see, the output neuron value is calculated like this. Y hat is equal to W naught plus W1 into H1 plus W2 into H2, like this. H2, H3, H4, whatever. So this is a formula we are using. Using this formula, when we calculate the value of output neuron, this value is ranging from negative infinity to positive infinity. And that's why optimization of weight is getting difficult. So we say that let's use exponential value. So when we use exponential value, it can't be negative. Okay. If I use over here exponential value, okay, now the output can't be negative. Okay, I'll show you in this thing. If I will use np dot exponential of any negative value, let's say 90, it will be positive. 8.19 into 10 to the power minus 40. Okay, if minus 9, then you can see it will be always positive, right? So exponential value over here, just a minute. Exponential value, what happened? Okay, fine. So the exponential value over here makes sure that your output will be positive. This output now can't be negative at any situation. Next modification we do what? We just write over here EY hat upon EY hat plus 1. This will be equals to EW naught plus W1X plus W2, sorry, W1 W1 H1 plus W2 H2 plus W3 H3. You can just do that. W0 plus W1 H1 plus W2 H2 plus 1. So now it will make sure that output neuron value can't be more than 1. It can be 0 or it can be between 0 to 1. Why it will be between 0 to 1? Because you see what we did. We took the numerator, right? Added 1 to the numerator, right? So it means it is like this, 5 upon 5 plus 1. Can it be more than 1? At any situation, it can't be more than 1. Right? So now this formula we can write like this: Z is equals to, okay, 1 upon, if you divide both numerator and denominator by the same value, let's say if I divide this numerator and denominator by the same value, W1 H1 plus W2 H2 E W0 plus W1 H1 plus W2 H2, right? So it will be what? 1 plus E, this will become 1, okay, and this will become 1 plus E negative of W0 plus W1 H1 plus W2 H2. Now this formula is used to calculate the value of output neuron, and the same formula that you can see here, okay. So this formula, when we use to calculate the, like, these will calculate the value of output neuron. Now that value, okay, whatever the value of output neuron we are getting, that value we will pass through this formula. This formula will generate the output in the range of 0 to 1. Okay, it means, let's say over here I'm getting an output as 0.85. Okay, my actual label is 0. Let's say the calculated value is equal to 0.85. The real label, let's say, 0. So error can be equals to what? 0 minus 0.85. Now this error, can be easily optimized. Okay, this error can be easily optimized, right? So it just reduces the magnitude of error, as well as now the output neuron is getting limited between 0 to 1, so chances of kind of random fluctuations also decrease. That's why my accuracy improved. That means now I have a model which is 100% accurate to identify a particular text is about cricket or is about chess. Okay, so let's say I'll write a text over here. New text is equals to today we have a cricket match. Right now it is like this thing needs to be kind of identified as 0. So how it can be identified as 0? First thing, I have to convert it into tokens, right? So how can you convert into tokens? So I can convert into tokens like this, or I have to convert into sequence. Actually, token is already there. I have to convert this thing into sequence of text. So I'll do what? Tokenizer dot text to sequence. Okay, here I have to give what? New text. Okay, so when I give the new text, okay, this will be converted into numerical sequence. New text. All right, it is just converted into numerical sequence. Now why only 4 words? Why only 4 numerical value? Because there are some words which are not there in the training, right? Like today. Today is a word that we have not used during the training. In the training, we don't have any word today. Do we have any word today? We don't have any word today. So that's why, as today is a word which is out of vocabulary, that means we have a word today that we are using here that tokenizer don't know about it, because during the training today is not used. Have is a word is not used, right? That's why it just know about 4 words. Okay, because in training we have not used those words. That's why only these 4. Next, we have to do what? We have to perform the padding so that we can give the same size of data that we had used for the training, right? So this thing we have to feed through pad sequences. Pad sequences is what we had used it earlier. Here, if you see, pad sequences doing what is basically converting all the things of size 5 so that it is a structure. So during the training, we had used a 5. That means for each sample, we have used 5 words. For each sample, we have used 5 words during the training. So for prediction also, we have to use 5 words. But here we have only 4 words. Okay, here we have what? Only 4 words. So I have to do padding over here. Okay, so in the padding, I have to tell this guy what I have to tell. I have to tell this guy that what should be the maximum length. Okay, that should be 5. Okay, that's why it added 0 over it. Also, and type also I can add, let's say padding is equals to pre-padding. Okay, so now it is what pad sequences. Okay, so now I'll do what? I'll just try to model dot predict what? The pad sequences. Okay, so when I do it, I get the outcome as 0.48, right? So now we will just compare this guy if it is more than 0.5 or not, because I get the output as between 0 to 1. If it is more than 0.5, okay, it will be what? It will be 1. If it is less than 0.5, it will be what? 0. Okay, so if I compare it more than 0.5, I'll get false. Okay, and then we will convert this thing into integer. Okay, so it is predicted as what? 0, and 0 we labeled what? Cricket. That means now I have a model which is recognizing the text related to cricket. Okay, let's define one more text. Okay, so I'll define one more text over here. This time I'll define let's say Viswanathan and Viswanathan Anand is a legendary chess player. All right, this is a text. Now I have to do what? I have to perform the this thing, that is this particular thing I have called. This guy will do what? Will convert into sequence and as well as pad it. And once we have the padded data, I can just use the model over here to predict. Okay, so now once it is predicted, we can compare if it is more than 0.5 or not. So it is more than 0.5, and then I can convert this thing into integer. Done. Right. So we have a model which is trained on the text data. Okay, and this model, this is our own model. Okay, which we trained on our own text data. Okay, we are not using anyone else. We are not using GPT. We're not using anything. We have our own model which is learned using the text data that we have. And this model is good enough. Whenever we feed any text data to this guy is predicting as 0 or 1. 1 stands for chess, 0 stands for cricket, according to our own data. Right? That obviously we can write more if condition and all to give the output as a chess or cricket. But this is how the text data is used to train a model. Okay. In the upcoming class, we will go deeper into it. We will try to explore how a language model can predict the word. As of now, it is doing what? It is just predicting 0 or 1. Okay, how it can predict the word, next word in the sequence, that is word predictions and RNN and other things. And thereafter, we will move to using the APIs. Okay, APIs of pre-built model like GPT, Gemini, Llama, right? How can we use them? Because A small size model we can create, but it's not, it's difficult to create a very large size model because model creation don't require only your coding skill. Large size model also requires high end system configurations. Okay, you require, huge GPUs and so many things. So if I can't create a very large size model, so what I can do, I can use the large size model that is already there, right? So first we will work on RNN, thereafter we will work on GPT and other things. So that is the thing for the today. Please let me know if you have any query to ask from today's session. I know for some of you who are not so much aware with machine learning or deep learning, things may be complicated, but don't worry about it. It is just the process I am telling you. These things, why I'm telling you, if you're not getting it, if you're getting it only 20-30% of it, that is also more than enough. These things I'm telling you just to create a picture that how actually text gets processed. Okay, how actually text gets processed, how vector are basically used, how embeddings are actually used, so that when I will use these terms with the GPT, right, you should not get confused like, okay, what I'm talking about. Okay, so these terms, when if you're going through these sessions, trust me, even if you're not so much aware with these things, don't worry, because these are not the part of generative AI. These are the part of deep learning. Okay, but I don't want to put you directly into that particular area, which in which everything will be a kind of will be just you know irrelevant for you. So if you have these understanding, basic understanding also, then the journey that we are going to start in the field of generative AI and agentic AI will become very easy for you, right? So that is it for the day. So if everything is fine, shall I close it for now? All right. Thank you, everyone. Take care. Thank you, Savik. Thank you, everyone. Thank you, Prasad.